In section 8.3 part 2, we get two big tests, the comparison test and the limit comparison test. I want you to think of the limit comparison test as your fallback. You start comparing, and if it doesn't work, you use the limit comparison test. So here's an example of a comparison test problem. Does the series converge or diverge? We think of it as a comparison test because it doesn't look easy. We might have to integrate it, but I don't even think I could integrate that because there wouldn't be a nice u-du pair to use substitution, and it would be a difficult trig substitution. So what I do is I take the terms I'm working with, 1 over the square root n squared minus 2, and I get rid of the least important term. I don't throw away more than one thing at a time so it doesn't get confusing. Well, throwing away for very large values of n, the 2 is irrelevant. So I'm going to throw away the minus 2. Now in the middle, we're always going to have some sign that says, did we get bigger or smaller? So remember that if you divide by something smaller, we're subtracting 2 here. If you divide by something smaller, you get something bigger. So the left side is bigger than the right side. And on the right side, when you've gotten rid of all constants and larger and smaller powers of n, you end up with something that usually simplifies. So the square root of n squared is just n, 1 over n. That's the same thing. So the series we're working with, 1 over the square root of n squared minus 2, is bigger than the series with terms 1 over n. Remember, this is an, and this is bn. These are two sequences, and when you add the sigma, they're adding. So now I'm going to talk about this guy. We went from one we don't know, question mark, to one we do know, exclamation point. We know the series from n equals 3 to infinity, we start with the same number, of 1 over n is a p-test, is a p-series with p equals 1, so it diverges. You keep adding these numbers up, keep adding them up, keep adding them up, and it'll go off to infinity. It'll never stop. So we ask, did this work out the right way? Was the inequality nice? Well, the thing we wondered about is bigger than the thing that diverges. So if you're bigger than something that diverges, the comparison test, so by the comparison test, our series also diverges. N equals 3 to infinity, 1 over the square root n squared minus 2. It doesn't say what it converges to. If we tried to integrate it, we would still have to use approximations like we saw with the integral test. So we can't get a nice easy sum for it yet. But we do know that it does diverges. So by the comparison test, this diverges also. Now, if you're ever doing a problem and your inequality is backwards, then that's when we fall back to the limit comparison test, but we didn't have to this time. Notice we stated both tests that were used. I have to use the p-test, so I mentioned the p-series, and I mentioned the comparison test. You need to mention the tests that you're using in order for us to know you actually understand what's going on. That's a big pitfall with the homework that says converges or diverges in a little box, is if you get to the test, you have to show us why. So make sure you're focusing on that and you're making yourself write sentences like this. So I'll be back with the limit comparison.